The 6 Series MSO is a mixed signal oscilloscope, perfect for validating and debugging designs with gigahertz clocks and gigabit data rates. It's ideal for looking at signals like DDR3, USB, and MIPI D-PHY. Now there's a lot of great things about the 6 Series, but in this video, I'm going to cover 6 of them. The 6 Series MSO has 5 different bandwidths, ranging from 1 to 8 GHz. This one here has 8 GHz of bandwidth. Bandwidth can be upgraded to any level at any time without returning the instrument for service. All instruments have a maximum sample rate of 25 gigasamples per second on all channels. This is always true no matter how many channels you turn on. A previous generation scope at 1 GHz bandwidth with 5 mV per division vertical scale and no signal connected shows 217 microvolts of noise. The 6 Series has a new front-end amplifier ASIC for very low noise at high sensitivity. With the same settings, this instrument measures just 58 microvolts of noise, a reduction of over 70%. I've connected to a bursty signal, and I'm using a visual trigger with a keep-out area to stabilize it. The analog to digital converters have 12 bits of vertical resolution, so you can see excellent signal detail. What I'm most interested in is seeing what's happening just before the burst. By turning on high-res mode, you can go beyond 12 bits, up to 16 bits. It works by taking advantage of oversampling while controlling noise through advanced filtering. This is overlay mode. It can be difficult to see signal details without changing the vertical scale. I can switch to a stack display mode. This helps you get the most out of those 12-bit A to Ds by allocating separate full-resolution graticules for each waveform. Each graticule represents the full dynamic range of the ADC. The 15-inch high-definition pinch, zoom, swipe touchscreen makes the 6 Series a joy to use. Directly position and scale waveforms instantly. Quickly turn on more channels. Each waveform and control object gets its own badge. Channel 1 and Channel 2 form an I2C bus, so I'll add bus decode. I can change settings by double tapping on the readouts. If I don't like the way things look, I can change the order of the waveforms. Or turn waveforms off altogether by dragging them to the trash. The 6 Series is really outstanding at analysis. I'll start with the cursors. The cursors ride along the waveform with both X and Y readouts, as well as a delta readout. The cursors can easily be moved using the touchscreen or the multipurpose front panel controls. If I want to make an automated measurement, I just drag and drop. I'll add a few measurements to channel 1. Amplitude, peak-to-peak voltage, and rise time. Each measurement includes statistics to help you get a handle on long-term variation. The badge shows minimum, maximum, and standard deviation. I can jump from measurement to measurement, or quickly find the minimum or maximum measurement. Results tables provide even more insight into measurements and their variation. A results table provides 2 sets of statistics. The columns on the left show the mean, min, max, standard deviation, and the population for the measurements on the current acquisition. The columns on the right show the accumulated statistics on all measurements made over all acquisitions. You can quickly see the behavior of a measurement over tens of cycles or millions of cycles. I can also look at a measurement's behavior throughout an acquisition as a trend plot. The measurement trend shows values for the measurement, in this case rise time, as it varies throughout the burst. You can also look at a histogram of the measurement to see if there are any values that happen more often than others. With advanced analysis tools, you can go deeper still. The good news is that these tools are just as easy to turn on as simple measurements. Advanced power analysis provides AC input measurements, switching analysis, and DC output analysis. But since this is a high-speed serial signal, power analysis doesn't really make sense. Let's look at jitter instead. Advanced jitter analysis provides tools that help you take jitter apart and determine its sources. A super quick jitter summary provides an excellent starting point for a detailed analysis. The 6 series comes with 4 1 GHz 10x low capacitance probes, so you can probe around your boards without loading down your circuits. Each of these 4 connectors is a flex channel input. By plugging in a logic probe, the input changes from a single analog channel to 8 digital channels. Digital waveforms have the same high sample rate and long record length as analog waveforms, making it easy to correlate analog and digital signals on the display. A wide range of other probes are compatible with the TekVPI probe interface, including optically isolated differential probes, single-ended active probes, differential probes, and current probes. The TekVPI interface delivers high-fidelity signals to the front end of the scope. It also provides a lot of convenience and helpful feedback. It provides power to the probes and enables communications from the scope to the probe and from the probe to the scope. These new TDP7700 active probes are perfect for measuring high-speed serial links with bandwidth up to 8 GHz. They are tri-mode probes, which means you can make differential, single-ended A-side, or B-side, and common mode measurements without having to reconnect the probe. This is a scope that can adapt as your applications change. Buy what you need today and add as you need to. Upgrade bandwidth to any level without returning a scope to service. Add a Windows operating system to run PC applications right on the scope. Add a built-in arbitrary function generator as a signal source. Add decoding and triggering for more than 13 different serial protocols. Add automated serial standard compliance testing or advanced jitter and power analysis. Add a DVM and trigger frequency counter for free just by registering your scope. And our engineers are continuing to add new capabilities and options.